Hi, thank you. Let me just make sure I have my place ready in my text. I usually don't have slides, but I prepared some. In philosophy, we tend to read papers, and I don't like fussing around. But my friend and colleague, Andreas Müller's son, showed me the magic of AI. So I was able to create from my outline. I didn't ask the AI to do anything, just a beautifully presented slide for this purpose. So I have some text to accompany it if I lose my place. But I'll just kind of work through the structure of the paper and extemporaneously give my thoughts from the slide, which is, I guess, what a slide presentation is anyway. So I'm Mike Cifone, lecturer in philosophy for a while. St. John's University. Since COVID, it's been online, and it affords me a level of nomadism in my scholarly and professional pursuits. I am the executive director and the co-founder of the Society for UAP Studies. Many of our colleagues are here. Please engage with us. We have lots of interesting events and activities and other possibilities that are there for the resources of the community. I will be, in a few weeks, almost German. I will be a research fellow at the Friedrich-Alexander-Universität in the Center for Advanced Studies in the Humanities at this university in Erlangen. So I will be here for a while. So today, the paper is called, it's all about the evidence, but what is the evidence? So it's a kind of a philosophical, sort of high-level attempt to work through what I think is a crucial sort of philosophical, methodological, and historical transition, a phase transition between two different contexts and methodologies of approaching the problem of the UFO as a subject of empirical research. So that's kind of the general topic, and today I'm going to focus on the scientific, the scientific study of what used to be called UFOs, which are now probably better called unidentified aerial undersea phenomena. I don't like anomalous because we don't know the extent to which they're anomalous. They seem to be, but that's the question, is characterizing an observational space within which it makes sense to say that any particular class or individual event that would be described as a UAP is actually anomalous, and for what specific reasons. So what I'd like to focus on is moving beyond, which is what I think that we see in this phase transition, a historical shift since 2017, I would say more like 2021, when you had the formation of the Galileo project, and IFEX becomes more interested in the UFO, UAP question, and then other academic groups get serious about doing the science and trying to determine the framework, right, within which that science can actually materially and socially emerge, and what it looks like. So what we're seeing, the argument is basically moving beyond case reports, which have their own limitations. I understand the methodological framework within which the case report analysis happens is fundamentally forensic in nature. And it's not clear the extent to which that has been a sort of a self-understanding of the practitioners of the investigation into UFOs confined to the case report, right? So this is a methodologically interesting question. We're exploring this in a series of working groups at the Society and getting together people in the law, and law enforcement and in the scientific community to ask the question, well, if UFO investigations had been done forensically, then what are the methodological forensic foundations of that practice? And then furthermore, there is this question of how that relates, that historical tradition, which I call classical ufology, how that is going forward as a new observational, experimental, and perhaps even a theoretical science emerges for the study, the empirical study of UAP. How are these traditions, which are different, they operate in different evidentiary context, how do they fruitfully, rather than antagonistically, interact? That's a crucial question, I think. So the fundamental problem, as I'm articulating it, is that traditional, isn't it nice the AI can do little things like that? These are real images. I asked it not to create AI images because it can't do fingers and text, and it looks like bullshit, right? So that's actually, I think, a real text. Traditional UFO research, what I call classical ufology, it's generally speaking, right? I mean, even if the event happened, you're always coming to it too late, generally, right? It's a post-event evidence collection. Nothing, wrong with that. It's forensic and circumstantial in some cases, in many cases, the data. You're looking at historical case study analysis. And here what's sort of troubling and always bothersome, and quickly, when you read the UFO literature, you just sort of see that you could quickly exhaust the methodologically. It sort of proceeds in this juridical inductive rather than what I would call a kind of scientific demonstrative mode of thinking. And the logic is like who done it, what done it, is the question of the classical ufologist. What was what was it that caused the person to report their incident? What was it there exactly? Is it anomalous? Is it not? What is it? Is it extraterrestrial? Is it terrestrial? Is it a misidentification? That's usually right. And as science sort of wakes up to the problem, to the question, that is in a strict scientific and observational context. That is not definitive data. That's indicative. It's suggestive, right, of a certain structure to the phenomenology of the appearance of the UFO. What I will call, in general, Hynek used this term, which I think is appropriate, and this is a question, is this the object of the scientific and empirical research? The UFO experience. It's a complicated, right, sort of structure of an encounter with something, the physical characteristics of which are very interesting and puzzling, it would seem, from the way that the witnesses describe their experiences. And now the science is waking up to that kind of problem of very rigorously characterizing an observational, like Wes was describing, a very strictly controlled observational framework within which one can physically characterize a baseline understanding of what constitutes normal and what would be a departure from that, such that you could more precisely characterize the UAP in terms of its physical observational characteristics, right? So this is what we want. But we don't yet have, and the work of our colleagues at Hessdalen and at IFEX and at Galileo Project are establishing just sort of phase 0.1, which is the design of the observational context within which the data, which is controlled, relatively speaking, to the equipment that is well understood and well characterized, such that the data that comes from that could possibly present us with the basis for making a scientific demonstrative case for the nature and origins of at least some UAP, if not entire classes. And that's where we want to get to the point, right? Is the UFO problem a problem in fundamental science? Is it, right? What is it? Does it present with us evidence for new kinds of physics, or is it an application of some intelligence of physics that we do know, but we just don't know how to apply it? Right, and so as I'll say a little bit later, there's kind of an entire, right, a matrix of problems here that we're slowly working that out, right? So scientific ufology, just to put a point on it, has been confined to the studying of reports of phenomena rather than the phenomena themselves. As the great German phenomenologist once put it in his phenomenological research, to the phenomena themselves, right? And that's where we're headed in the new, what we call in our community now, after Kevin Knuth's massive, 95-page paper, the new science of UAP. This is where we're headed. So the historical context, I won't repeat it. sort of incidental evidence. It's often, the cop is driving down the road and, and suddenly it happens, or the air traffic controller is directing, a plane to come in for landing, and suddenly on the, you get this strange signature. There's dozens of cases like this. It's incidental to the specific functioning of the equipment on which, if we have recordings, it's recorded. Those pieces of equipment, those measuring instruments, are not generally calibrated for the kinds of phenomenology that's being reported and even sometimes captured on radar, right? Famously, we have the Japan Airlines case in which we actually have the radar data from which you can make an actual plot out of which the kinematic data can be extracted, which Daniel Kuhlman, in a great little text in 2023, actually did, I think, maybe for the first time. I never saw an actual plot from raw radar data returns of a UAP against a commercial airliner from which you could make the kinematic calculations, which of course were just, were impossible. 10,000, peaking at something like 10,000 Gs or something, right? So we're exiting this limited framework because that's what we want, is controlled observations, right, of UAP incidents that can begin to not only first further characterize what it is that a UAP is in a certain observational sense, but also the extent to which, when we do capture it, it is anomalous, and to be able to sort of quantify that and then give us some data on which we then can send to theory as potential evidence for a new framework, maybe, right? That's the question. To apply this distinction between the forensic and the sort of more strict observational, sort of scientific demonstrative context, which is the foundation of science, right? Science, if you look at, for example, the foundations of terrestrial and celestial mechanics, you were not doing forensics. You were doing observations of relatively stable observational targets from which you could extract very precise geometrical facts which were summarized in the laws of Keplerian motion for planets. And then the Galilean experiments, right, in the 17th or 16th century formed the basis of terrestrial mechanics, from which you extracted certain stable relationships. And then you had the 17th century development of the unification of the two mechanical spheres into the universal theory of gravity. Based on that, it was archival in a sense, but it was exacting and it was scientific and it was demonstrative, right, in a very rigorous sense. And that gave us the fundamental principles of motion on which all of astronomy and later astrophysics are based. So if there's any forensic application of a science, the question always is, it's a forensic application of what science? Because there is a non-forensic principled basis on which we build a forensics, which is not, we don't have that for UAP. That's part of the problem, right? We don't have that. So you can apply this distinction to to re-examine and relitigate the problems with the Condon study, was the proposal in the paper. And so this is sort of the shift you now see. You know, the problem with the Condon report, which purports to be a systematic examination of the UFO problem, just turns out to be a really shitty forensic investigation, as many researchers would later point out, right? First among them, probably it was James McDonald in a famous lecture and text called Science and Default. The problem is simply that we are dealing, you can't require the strict standards of evidentiary and demonstrative proof for phenomena that present themselves only within a forensic context. That's the loop. When the skeptic comes out to dismiss, often the standards that they presuppose are incommensurate with the evidentiary context within which the phenomena are actually encountered, which is retrospective, it's incidental, it has all of these forensic limitations. Right? And that's the answer to that. I mean, and the point is they're right, but so then we need the non-forensic context out of which the non-forensic data can be produced, on which then we can come to firmer conclusions instead of being trapped in the sort of endless question about who done it or what done it. That is the limit of the archival and classical research into the UFO problem, right? This is the thing. So the contemporary approaches are hopefully proliferating, as the great Chairman Mao once said, right? Let 1,000 flowers bloom. This is the point. We want a lot of, and Matt, I don't mind too many groups, if they're doing different stuff and organizing the space in interestingly and fruitful different ways. I know you need money and we got only a finite amount of resources to go around, but the billionaires, they're interested. So, but anyway, we've got at least 4, Stalin is probably historically one of the oldest, sort of contexts of sort of non-forensic, observational recording. I mean, there are always going to be forensic elements, right, to science. So these programs have established and are establishing research frameworks for systematic observation, and therefore the argument is, right, we're moving beyond forensics to something that looks like science, right? We don't know what that science is. We don't know its nature yet, so as a philosopher of science, I can't say much about it, but I want to help, like Socrates, I want to help it come into existence. The midwife, right, this is Socrates' practice was midwifery, right? Helping it come into existence. So what we want, this is the sort of I think the gold standard, this is what we all want, right? We want the virtuous circle of observation telling us what there is, taxonomy, we want to classify the observations, right? Because UAP are all sorts of stuff. I mean, sometimes it looks like plasma, sometimes it looks, like a structured object. I mean, sometimes it looks like a sombrero. Sometimes, if you look at the case literature, it is incredibly phenomenologically, morphologically diverse, just with respect to the target, the UFO, right? You've got a whole papers now written on, the classes of shapes, for example. And then there's as the great Neoplatonic philosopher once argued, that you can see the nature of something in the grace of its movement, right, is the essence of its soul. So how does the UAP move, even? Just the ways in which it moves. There's, like, the literature is filled with taxonomies even of movement, like you have the falling leaf phenomenon, right, and all of these kinds of strange dances and zigzags, and, right, that's a whole sort of taxonomy of the motions, the grace of the movement of the UAP. So we move from observation of the phenomena to taxonomizing it and distinguishing between different classes of UAP. This helps us, right? So it's kind of like we need to do zoology or something, right? We need taxa. And then we have something on which to theorize, finally. So depending on the differentiation that is achieved taxonometrically with respect to the observations, we can then get clearer on what are the theories, the hypotheses, and then we can model, because we have something to model. And then we can test. Once we theorize, we send that over to the experimentalists, because the theorists tell the experimentalists what else to look for. Based on my theory, I make a prediction, and I can tell the experimentalist, here's how to, here's what you should look for, and here's what you should build to look for it. Like we have this in particle physics, for example, right? And it's governed by theory, and then sometimes you discover new theory, because the theorists are like, look, I had 2 radiation curves, the Rayleigh-Jeans and the Wien's law and black-body radiation. I can't get these 2 things to come together, but this is what my experimental evidence is telling me. You figure it out, and Planck, of course, in 1900 figures it out, right? So that's what we want to get to, that stage where we have this virtuous cycle. Observation, we're taxonomizing it, we're theorizing the secure data that we don't have this forensic indeterminacy with respect to. We send it over to experiment, and then the experiment produces new observations, and so on and so forth, right? And so we want to set up this virtuous circle. Rich observational data will enable differentiation of types and targeted theoretical development for each classification. Some UAP, like I said, appear to be one thing, plasma, which seems natural. Others appear, of course, as structured objects, and sometimes like both. You know, sometimes UAP seem to morphologically vary, even, which is interesting. And then, you know, this sort of cycle is going to depend really on what the observational evidence is. I mean, so let's like suppose we get that, you know, that clear image. I mean, we had a fuzzy, you know, image of the Tic Tac from 2004, the famous Nimitz case. But let's suppose, you know, we captured that on one of the, you know, the Galileo observatories, or an IFEX, an observatory. We had a clear, crystal clear image of a smooth object with no flight surfaces demonstrating anomalous kinematics. Let's just suppose we have that. Now what happens? Right? We have a number of questions, and that will differentiate the practice of the science as a result, it seems. Engineering. How the hell is an object, a smooth, apparently structured object with no flight surfaces, capable of undertaking those kinds of kinematics that are now conclusively affirmed in a multimodal observational platform like the Dalek or whatever? How was it created? Theoretical question. What theory explains 10,000 Gs? I mean, if you look at the Japan Airlines plot, the UAP that Daniel Kuhn, who by the way was he worked at the Niels Bohr Institute. I mean, he's a particle physicist. He's like many of you here. I mean, he knows science. When you do the plot, the UAP was just simply jumping in space around the Japan Airlines. It was in front, then it was in behind, it was in front, it was behind. And you see this on the plot, right? And you've got 3 radar recordings. You've got the air traffic controllers. You've got the air traffic controller is like, yo, let me call NORAD, you know. NORAD, you hear it. You hear the NORAD desk officer like, okay, let me check the radar. Yep, there is a target, uncorrelated. ATC calls back to the captain, okay, we've got the target there, and they're calling out the distance. And then the captain turns on his weather radar, and then he narrows the beam on the Doppler radar to see if he can bounce it off the object, and lo and behold, it's on the onboard radar. How's that a temperature inversion is the question, right? If you got it on board the radar, I mean, right? So, and it's pulling 10,000 Gs. How is that possible? A material object interacting electromagnetically with a structured object with no apparent flight surfaces. The guy said it looked like, you know, it's a strange phenomenology. It looked like a walnut. It was bigger than like 5 aircraft carriers. It was, you know, a strange thing that he alleges to see. How do you explain that? What theory explains it? Is it possible to do a back-of-the-envelope calculation with respect to general relativity and give me a solution in terms of Einstein's field equations in an atmosphere? Put those initial conditions to the EFEs and see what you get. Is there a solution to that question? We're not just talking about warp drives, right? We're talking about modeling, at least on the back of the envelope, a particular phenomenological situation in which you've got the UAP in the atmosphere pulling 10,000 Gs. You know, who's done that calculation? Probably, I don't think anybody's done that, actually, with those initial conditions. Is that a possible solution of Einstein's field equations? Is general relativity even the right way to think about those kinds of kinematics? Right? And so that's I think, you know, where a lot of us want to go. Is there new physics involved behind the engine? You know, there's the engineering question of how do you engineer the physics that there is, but is it known physics? You know, in other words, is it an application of known physics that is unknown to us in terms of the application? Or is it an application of physics that we don't even know, right? It's the question. But we need data, right? We need these observations to be precise enough to be able to give us that information, which then can form the basis of a demonstrative science, in which it's possible to determine new fundamental principles, right? But the situation is complicated. You're dealing with, right, in science, we don't typically, right, you don't typically try to deduce new physics from structured objects. Like, we do that with nature. We look at nature, and then nature behaves in a very stable, like Kepler, which is the foundation of, physics and many other sciences. This is sort of the gold standard, is nature discloses a structure to you. You geometrically represent that, and then you write down exacting laws with respect to those observations that, because of the stability of nature, are in some sense both spatially and temporally universal. I mean, that drove Newton, right, in his universal theory of gravity. What happens on the Earth is not different fundamentally from what happens at anywhere in the universe, right? And that's how science is done, right? So, but then there's the other question, which is not a question of physical sciences, but what is the science to help us answer the question of what is the origin? What is the agency? Science doesn't study the intelligent origins of things because there isn't really a question on Earth. You've got human beings, and then you've got animal intelligence. We're the king of the hill here, right? We are sovereign in some methodological sense. We don't have to deduce a form of intelligence from an artifact. So what's the science for that? That's probably a very complicated interdisciplinary affair, we think, right? We would think. But that's a separate question than the engineering and then the theory question. And as we get more and more refined observations, these theoretical, these paradigms, these frameworks will differentiate, systematically based on the character of our observations, which, by the way, may take many decades to produce very good data and evidence. It could be, right? Because, I mean, the observational window that you're looking at, I mean, it's a vanishingly small portion. I mean, at least, when Kepler, and the early astronomers are looking, the field of vision is almost out to, they didn't have the concept of infinity, but it's effectively infinite in a sense. I mean, you've got such a wide, so you could sort of see the entire solar system, right, from just one. But so is that, one of the problems is how much of the observational space should you have open at all times recording? But it's a huge data challenge, and that's why we go to hotspots, right, to kind of try to buck to account for the problem. Anyway, so you see the issue. I don't know if we need a new paradigm shift. I don't know, in a big sense. But we certainly do need a paradigm shift in terms of how we approach, right, UAP. And my argument is that we need a paradigm shift towards a comprehensive kind of empiricism. I'm an empiricist. I'm not a Humean, I'm not a traditional empiricist. I follow more William James with a little bit of sprinkling of Deleuze, maybe a little bit of Hegel there and Kant, but a kind of radical empiricism. And I'm also a disciple of the radical Enlightenment philosopher Spinoza, right? I think this is an important framework with which to think, but that's a longer question. So what I think we need is to focus the object of our empirical efforts, at least initially, and even while we differentiate towards more subspecialties in UAP science, the focus should first, of course, be the UFO experience. I mean, all science is based in experience. We often forget that, but that is the foundation of all science. It's experiential. And this was a point that Husserl made, the great German philosopher, often, over and over again, right? And we can't forget that. Everybody should read The Crisis of European Sciences, the thing he wrote just as World War II was on the horizon and Hitler was elected in 1933. That's the year I think he dies. And that's the year his book is published. So a newfound empiricism must encompass qualitative, quantitative, and even, that's why it's radical, even cross-relational data which covers and crosses the mind-matter divide, which is the fundamental cleft between the two aspects of the empirical world that have not found a unified framework yet, which is the question of the quantitative, laws by which matter operates and the manner in which we understand the dynamical unfolding of mind. We have this gap. Yeah? And this is the source of, lots of speculation and lots of consternation over, is consciousness an element of the UAP experience? If so, how? Well, the problem is we don't have a theory that can systematically bring together matter and mind. That is an open question. Even with respect to consciousness itself, by last count, there are 320 theories of consciousness. So the problem, and Matt Shadagas, you're absolutely right. I mean, you don't want to compound the anomalies, right? You don't want to add too much too soon, right? Because even without mentioning aliens, UAP, whatever, dog whistles, you already have a problem of consciousness, irrespective of UAP, right? It's already a problem. And then you want to ask the question, how does consciousness fit into the, well, we don't know how to understand consciousness in a coherent and unified way. And that's an open question. And you want to smash two smashings of questions that are unclear doesn't produce clarity, it seems. But maybe the friction will. So we need to have an empiricism of a radical sort that at least keeps in mind that we begin with an experience. And that's it. I'm done. I'm done. So I didn't need my security blanket after all. I don't need the text. All right. I guess I can hold this.
Thank you very much. And we have time for one or two questions.
Yeah, great presentation, Mike.
Yeah,
Thanks.
thanks.
Coming back to that circle that you drew.
I need wine, by the way.
On the one slide.
Yeah.
Yeah, maybe we'll look at it.
Yeah.
You already said that from observations, we will probably move on to different, call it research programs or whatever.
Refinements.
How do we make sure that we grasp the whole thing? Because
you need to read philosophy.
Contrary to all the other examples, and of course contrary to all the other examples we can have, UAP are unidentified.
Yeah.
We must not forget, it's not space aliens, it's not pure psychology. We do not know what it is. And if we do not know what it is, we would not know if we can grasp it fully. That's a fundamental problem. So I would pose that this circle must contain getting rid of UAP. Because we want to identify what it is. The one day you formulate a theory, you would have something else than UAP. Right?
And I mean, that's why it's important to maintain a connection with what I call the classical tradition of ufology, because that is an archival resource that tells you the structure of the phenomena, like how it presents. But the problem is when we shift to this demonstrative, what I call the non-forensic sort of science of UAP, the shovel has to go down somewhere. I mean, you have to start with everything first in some sense. We have to characterize. It turns out, like, we don't really know what's up there. We don't really, in some sense, we don't understand actually what's happening in a detailed enough way to know what is normal against which we can definitively determine an anomalous occurrence with respect to that, right? So there's a real profound sense in which the science of UAP, and I think this is the talk we gave in Kiruna last year, it's bringing it down. First, we got to come down to Earth. And we have to understand the terrestrial before we can understand anything else. Because in a sense, this is an exercise in self-understanding. And understanding the Earth even deeper and better. And that's one of the sort of side consequences of the science of UAP, which it has, I think, much wider implications for the manner in which we conduct our sciences and the grasp of this whole that we're trying to see, which we don't, in fact. We shouldn't allow the successes of science to lull us into sleep thinking that we understand, right, the mesoscopic realm. It can be very unfamiliar and strange, possibly, right? We can't forget that nature loves, as they used to say in ancient Greece, nature loves to hide, right? So this is the thing. Did I prevent anyone else from asking a question?
So I see no question immediately. So then I would, yeah, yeah, okay.
Thank you very much for the event here. So thank you very much for organizing the whole event. I'm very grateful for it. My question would be, do you consider hard evidence, be it corn crops, circles, or the trifectal mummies in Nazca? I don't know about it, but the crop circles, there's also the video evidence of the UAP in conjunction with the crop circle just appearing. So is that also something that you would consider as hard evidence?
No.
Both there's I think sometimes the radiation that is left behind in crop circles, is that, you consider that hard evidence?
No, no, it's forensic. It's a forensic evidence of some phenomenon that, if people wish to study it, should be studied very carefully to move it outside of a mere forensic context into, a more observational context, which is, which is, has been rigorously determined, with respect to the instruments in relation to the phenomena. I mean, it's like any other problem. So all of these reports and stories and so on, I'm not dismissing them. It's just that, it's a whole rich field of forensic evidence for what we don't quite know until we transition into this kind of observational science. We are focused here on unidentified aerial and undersea phenomena, and maybe in the course of that more rigorous study, we have some indication as to how these other kinds of phenomena can be explained, but we don't really know yet. We don't really know much, right? We're just setting up the observations, in a sense. Thanks.
So, okay, thank you.